trig graphs. Well, let's say just your basic y equals sine. Just so you don't think I'm making this stuff up. We know that's 0, 90, 180, 270, 360. Well, notice how if I went 1 in all 4 directions, 1, 0, 0, 1, negative 1, 0. This should look familiar with your quadrantal angles. 0, negative 1. So if I wanted to graph y equals sine of x, we're going to start with 0 degrees, 90, 180, 270, 360. Notice how if I wanted the sine of 0, it would be, because remember, sine cosine, it's at 0. Sine of 90, 1. Sine of 180, 0. Sine of 270, negative 1. Sine of 360, 0. And how if you connect the curve, connect the dots to make a curve, that is one complete sine curve. And now it goes on forever and ever in both directions. But one complete cycle is 360 degrees as long as it's your traditional sine curve. And notice how it never goes above 1 or below 1. That's why whenever you hit like sine of 2 on your calculator and you're in degrees, it doesn't exist. Or even cosine, we'll get to in a second, cosine of negative 3 is below negative 1, so it doesn't exist. Well, if we've done sine, let's do cosine. Still got 0, 90, 180, 270, 360. So now let's do the same, but with cosine. Cosine of 0, 1. Cosine of 90, 0. Cosine of 180, negative 1. 270, 0. 360, back to 1. And if you did the curve, notice how it looks like this. Now remember, it keeps on going forever, fluctuating between 1 and negative 1. And if you look, and if you extend this back right here to, we'll say negative 90, notice how from here to here to 270 is the same thing as 0 to 360 for sine. So actually, cosine is just a sine curve that's been shifted to the left 90 degrees. Well, and there's all sorts of things you can do to it. Let's say if I had 2 times the sine of x. Well, what the 2 stands for is the amplitude or the height. So instead of going from 1 to negative 1, it's going to go from 2 to negative 2. Now, the good thing is there's nothing weird with the angles. So they're still going to stay 0 to 360. Nothing shifted. So it's still going to be the same. A hump above, a hump below. That's it. Let's say if you wanted negative 3 sine of x. Same thing. You still have height of 3. And you still have 0 to 360. But since it's negative, it's just going to do the exact opposite. So instead of going up and then down, it's going to go down and then up. Now let's say they put the coefficient between the sine and the x. Sine sine of 2x. Well, what this means is it has to do with a period change, that there's going to be 2 sine curves for every 360 degrees. So that means if you divide 2 into 360, you're going to have 1 complete curve every 180 degrees. So you still got 1 to negative 1, because see, there's coefficient of 1, nothing out front. And see, ordinarily, your graph would look something like that. I'll just do it real light. But in this case, it's every 180 degrees, not every 360 degrees is 1 sine curve. So that means from 0 to 180, we're going to need this shape. So we're going to go up and then down to make 1, up and then down to make 2. If there was a 3, that would mean there's just 3 curves in the 360 degrees. So that would mean every 120 degrees there would be 1. Well, let's do a cosine curve. Let's say 5 cosine of x. Remember, the number out front means coefficient. So 5, negative 5. Nothing weird there, so still 0 to 360. And the only difference is, since that's the height, it's going to go up 5 and down 5. And remember, cosine starts at the top. It's going to cross and come back up. It just has a height of 5. Now let's say if you did cosine of 2x, where you had 2 curves, the easiest way to do it is you can just show me one section, and you can still show me one curve. It's just, instead of showing 0 to 360, 0 to 180, because there's 2 curves in the 360. So there's only 1 curve in 180 degrees. Now tangent, let me put this back to the side so we can refer to it. If I said graph tangent, same thing. If you did it, tangent, remember, is sine over cosine. So we got 0, 90, 180, 270, 360. Tangent of 0, 0 over 1, 0. Tangent of 90, 1 over 0, undefined. Tangent 180, 0 over negative 1, 0. 270, undefined. So I see you're like, oh, I'm seeing a pattern here. Well, notice how you know that those are vertical asymptotes, so it can't cross, but all you have is a dot. Well, let's say if I did something like tangent of 60. You know that's square root of 3, or 1.7. So that would be, let's say 30, 45, 60. So 60, that's going to be up. Tangent of 45, 1. Tangent of 30, 1 over square root of 3. So we're going to guess about there. So what's happening is tangent looks like this. And if we added 90. Now for tangent, you only have to do 1. If it's negative, it has the same asymptote. It's just going the opposite direction. So if I had negative tangent, let's just say between negative 90 and 90, or 90 and 270, instead of going up, it would go down. That's the only difference. It's the exact opposite. Now, one more thing, and we'll handle the reciprocal ones on the next one. Let's say they just throw you everything they have. Okay, you know that A2 has to do with the amplitude or the height. 3 has to do with the period change, in other words, divide it into 360. But then that leaves the 100 and the 5. The 5 is the center line. The 100 is the phase shift. So the good thing is I only make you do one. So as far as one complete section. So center line is 5. Amplitude or height is 3. So add 2, subtract 2. 4 tick marks. Now before we get to the period change, we have to know where to start. Well, the phase shift tells us where we start. And you look at this and see what makes it equal 0, which is negative 100. So that means your degrees are going to start at negative 100. It's positive sign. So you know it's going to look like that. And for your last number, where does it end? Well, if it has 3 in a 360-degree period, that means there's 120. Every 120 degrees, there's another curve. So if I said negative 100 plus 120, that means I'm going to end at 20. Just like if I had negative 4 plus 3 sine of 2 x minus 50. Center line is negative 4. Height of 3. 4 tick marks. You know it's sine, or I tell you what, let's make it cosine just to be different. So start at 1. Crosses. Okay, we'll come back to how many we're going to have. First, we're going to do our phase shift. So what makes that 0? Positive 50 is where one of the curves is going to start. If we want to find out where another curve is going to start, remember it's always 360 divided by this number, 180. So if it starts at 50 and it's going to go 180 degrees, 50 and 180, 230. And there's your curve. Next, we'll do reciprocal functions on the next one. Hope this was of help to you. Have a great day.